friends, here in this video we are going to see a problem on projection of lines which is inclined to both the planes. So here is the question. A line AB 70 mm long has its end A 10 mm above HP and 20 mm in front of VP. The end point B is 45 mm above HP and 70 mm in front of VP. Draw the projections of the line AB and find its inclination with HP and VP. So this is the question in front of us. First, I'll write down the data, and in such problems, we need to have at least 5 parameters to solve the question. Let us see how many parameters are there. A line AB 70 mm long. So that is the TL or true length of line AB 70 mm. Has its end A 10 mm above HP and 70 mm in front of VP. Draw the projections of the line AB, and then it is also given the end point B is 45 mm above HP. This was 20. Draw the projections of the line AB and find its inclination with HP and VP. So we need to find out the inclination, that is how much is theta, inclination with HP, and phi, inclination with VP of the line. So this is the question in front of us. Now let us start with the solution part. Now as we can see here, point A is 10 mm above HP, 20 mm in front of VP. I'll start with this, that is locating point A first. So point A 10 mm above HP, 20 mm in front of VP. Next, even they have given the information about point B, that it is 45 mm above HP, 70 mm in front of VP. So 45 mm above HP will be seen in VP. So first, drawing a light line over this light vertical line, I am marking 45 mm. Drawing horizontal line through it. Now this line is 45 mm above HP. Which is seen in VP. And 70 mm in front of VP. Now, we know that point B will be 45 mm above HP, 70 mm in front of VP, but where it will be, that location we don't know. For that, what we can do here is, the true length of the line is given 70 mm, so I'll take 70 mm in the compass, keep the point on A dash and cut this line. Measuring 70 mm, keeping on A dash, I am going to cut this line at 45 and keeping it on point A, cutting this line which is at 70 mm distance. Now here I am getting the locations. This will be called as B1 dash, and this I'll say it is point B2. Now when I connect them, that is going to give me the true length of the line, and the location of point B is known. Now these are the true length, and if the line is inclined to both the planes, that is HP and VP, in that case both in the front view and top view we are not going to get the true length but the apparent length of the line. So the next step would be to get that apparent length. For that, here I am extending a light horizontal line from point A dash, similarly from point A, bringing B1 dash onto this horizontal line. That will give me the point B1. Next, here this line which is passing through B dash, that will be called as locus of point B. Next, I'll measure this distance from A to B1 and then transferring it onto this locus. So where it is cutting this line, which is the locus, that will give me point B. So joining it with the help of a light line connecting A and B. So here I am getting the true line, which is here. The true line is from A to B2, that is the true length, whereas AB indicates the actual length of the line. So actual length will be made dark because this is the actual line, and the true length should be medium dark. Next, this is the inclination of the true length. Since it is in HP, it means this shows the inclination with VP, that is phi. We need to find this value. Now in a similar manner, I'll get the actual length of the line in the front view. For that, projecting this point B, upwards, it means within this location where the top view has ended, similarly the front view should also end within this distance. So now in a similar manner, like here we were having B2, I'll project this B2 in the front view. That will give me the point B2 dash. Next, measuring the distance A dash to B2 dash. Getting this as B dash. Locus of point B. Then again I'll make the actual length of the line A dash B dash dark. and the true length, which is a dash b1 dash, medium dark. Here the inclination of the true length with HP is seen in VP. This is theta. Then I'll measure the angles here. 30 degree. So I'll say that therefore the inclination of the line with, this is theta seen in VP, but it is the inclination with HP. So the inclination of the line with HP, theta is equal to 30 degree. First answer. Similarly, I'll measure phi, that is 45 degree. Inclination of the line with VP seen in HP, that is 45 degree. The second answer. Next, this is the true length of 70. A dash B dash is called as elevation length, that is the apparent length in the front view of the line. This is called as PL, apparent length of the line in the top view. And with this, the problem is completed.